Hello, and welcome to your next lecture for Math 171. My name is Drew Collop, and today we're going to be talking about signed numbers. Again, we're talking about very basic math here. We want to make sure you have a strong foundation before we build on that. Please follow along today. Hopefully you know this content. So what we're going to talk about are signed numbers. And as an example, we're going to use the fact that maybe you worked all summer to save money for your tuition. At your job, they give you a paycheck. So we will call a check a positive amount. Positive means it's going into your account. So your account is going up. But as we know, people have bills. Bills come out of your account. So we will call bills a negative amount. And just for simplicity, we'll put a positive sign with a circle around it, meaning positive, and a negative sign with a circle around it for negative. So let's go through and look at some examples here, and we'll try and see how signed numbers work. Once again, you probably already know this. We just want to make sure everyone's at the same level. So you worked all summer, you had a really good job, and you made $9,000. So your bank account at the end of the summer is $9,000. Some good money there. Your last paycheck comes in when you're off to school, and you get a paycheck for $1,000. Really good job you had. So it's a check, it's going in, so it's a positive value. So we're going to add a check for $1,000. So we have our $9,000 to start with. Keep the units in there. We'll add to that, we're adding to it, a check. A check is a positive value. So we're adding to it positive $1,000. And as you can see, we have two signs, plus and a plus. And in this case here, we are adding $1,000 to the $9,000. So at the end, we have $10,000 in our bank account. Pretty basic stuff. Moving along then, now you get your college tuition bill. The tuition bill is $2,000. This is not realistic. These are just numbers. So this is a bill. The bill, we're going to add a bill, which is a negative amount, for $2,000. So that means we're going to take our $10,000 that's in our bank account after we get our last paycheck. We're going to add to that a bill. So we're adding a bill, which is negative $2,000. So here we have a positive sign and a negative sign. In this case here is an odd number, so we are going to, in the end, take away 2,000 from 10,000. So in this case here, we have $8,000 remaining in our bank account. Pretty basic stuff. Let's get a little bit more complex here. Okay, so the employer realizes, oh, your last paycheck wasn't supposed to be $1,000. It was only supposed to be $500. So they've overpaid you by an additional $500. So they're going to deduct a check from your bank account. So we're going to subtract a check for $500. So here, the bank account now is $8,000. We're going to subtract away, take away a check. A check we said is positive. We're going to subtract away a check for $500. Once again, you can see we have an odd number. We have both a positive and a negative. In this situation here, we're going to subtract away $500. Even though it's a check that's positive, we're taking it away. So in this case here, this gives us $7,500. So here's the idea of taking away a positive number. Lastly now, your tuition bill comes in. Congratulations, you were given a bursary. A bursary is oftentimes taken from donations to the college, and they help out students. So in this case here, we're going to subtract a bill. Right? Your tuition is a bill. We're going to subtract a bill for $500 owing to you. So in this case here, we have $7,500, and we are going to subtract a bill, which is negative, for $500. So here we have two negatives. Two negatives together make a positive, right? In this case here, I'm taking away a bill. I'm taking away a negative number. So you get the bursary, it's money to you, so your account goes up in value. So we're back up to $8,000. So in this case here, we had two positive values. A positive and a positive equals a positive value. Here we have a positive value and a negative value. Positive and negative in the end makes a negative value. Next, we have a negative and a positive. Again, a negative and a positive makes a negative value. And lastly here, we can see we have a negative, and both of those together make a positive number. So two negatives make a positive. This is one of those principles in mathematics. Hopefully you are already aware of it. And I tried to demonstrate it using a sort of a real world example, somewhat real world. Let's try and look at that now in terms of a number line. We talked about number lines in our last lecture. Let's work with some number lines. We'll work with number lines with using the same sign and number lines using different signs. Let's build a number line in each of these boxes to start with. And last day, we were talking about putting a scale on the number line. So here we're going to take 2 and add 3 to it. And of course, we know that's going to be equal to 5. So we have to make sure that under number line, our 5 is there. Let's put our arrows on the ends to make sure it goes off in either direction. And we'll make sure we have 5 on the number line. So we'll start there and we'll break it down, trying to make sure every jump from one number to the next is equal spacing, because each of these, we want them to be to scale. There's no numbers to start with. Let's start at our 0 value here. And then what we're going to do, we're going to move from 0 to 2. And then we're going to move 3 more. 1, 2, 3. You can see here, in fact, this is how we get 5. So on a number line, this is how math is taught in elementary school. And you can see we can use a number line to do some basic math. Hopefully you know this. You don't need a number line. If you don't know how to do this, I question whether or not you are going to succeed in this course. But we want to break it down to the basics. And again, remember, this is going to be applied directly to your graphing in the laboratory. So you have to understand how to plot numbers on a number line. Eventually it will be in 2-dimensional space and maybe even 3-dimensional space as things get more complex. Let's deal with the other one. Now we have -2, and we're going to add to that a -3. So same signs, both negative. We're adding them together. When we add numbers with the same sign, we keep that same sign. So here, of course, that's going to be a -5. So we want to make sure we put that on our line here. So let's start at -5, and we'll break it down. -4, -3, -2, so on and so forth. Here we will start at 0 again, and then we go to -2 right here. So -2 is where we are on the number line, and then we're going to add -3 to that. So we're adding to it. We go in the minus direction, 1, 2, 3. In this case here, we are at -5. Take-home message here, when you're adding numbers with the same sign, you keep that sign. In this case here, +2 plus 3 equals +5. In this case here, -2 plus -3 equals -5. Basic principle. Again, hopefully you know this. That was talking about when you have the same sign. Let's talk about when there's different signs on the numbers. Right here. What if the signs are different? Again, I want you to practice this at home. It may seem very basic, but we want to make sure that everybody has a strong foundation to build upon. So here we have 5 minus 6. So we have to go up to 5 first and then go down to 6. So we have to make sure that we're at minimum going up to 5. And of course, you know what the answer this is going to be. So make sure you have all the values you need on that number line. And put -4 in there. So now we're going to start at 0 again. And then it says we go to +5. So We'll go all the way over to positive 5 right here. And then it says we take away 6. So if we're on a number line, we can go 1, 2, 3, 4, 5, and 6. And of course, the answer is -1. But you can see how we can do that on a number line. Let's do the next one as well. We have -7 plus 2. We have to make sure we get -7 on there. So I'm going to start my scale at -7 and work my way up, going in the positive direction. So once again, we'll start at 0 on the number line. We'll go to -7 all the way over here. And then we're going to add 2 to that. Be careful of this. Sometimes students can forget this. We're adding 2. We're not going to -9. We're adding it. The number's getting bigger. -7 is a low number. When we add 2 to it, we're going to go in the positive direction. 1, 2. In this case here, the answer is -5. So, take-home message here, if you have 2 numbers and the signs are different, you take the difference between the 2 and you keep the sign that is of the greater magnitude. Let's look at the difference between 2 numbers. So the difference between 6 and 5 is a value of 1. And you can see here, 6 is a larger number than 5 and it is negative, so the answer is -1. Same here, the difference between 7 and 2 is 5. The negative is on the 7, the bigger number, so again, -5 is going to be the answer. Hopefully, this makes sense to you. You probably haven't seen this sort of math in many, many years, but we are going to apply these principles to your laboratory work. So understanding how to work with a number line is pivotal. So let's work through some of these without using your calculator. So this is one of those times I'd like you to pause your video, and I'd like you to honestly don't use your calculator, do it in your head. Again, this is in the privacy of your own home. Hopefully you've downloaded the notes from our website and you can give them a try yourself. So pause the video, give them a try. Hopefully you've tried them all. Let's take them all up. So you have, if you like to, you could have used that number line. Ideally, you can do this in your head. -7 and -7, -14. 4 and 6, 10. 2 and 4, 6. We have -5 and -2. So we have -5, we're adding to it another negative number. So this is going to be -7. We have -3 minus 5 gives us -8. We have 7 that's negative plus a positive 7 here. This is going to give us 0 as our answer. -4 plus 6. In this case here, we're going to start at the -4 and add 6 to that, and this gives us +2. We have 2, take away 4. We're starting at 2. We move down 2 to the 0 and move another 2. This gives us -2. Now here's a situation where we have 2 negatives. What happens when we have 2 negatives? 2 negatives make a positive. So we have -5, and then we're taking away a -2. So we're adding 2 to that. In this case here, it's going to be -3. Lastly here, we have 3 minus 5. We have 3 on the number line. We take away 3 to get to 0, and then we have 2 more remaining. We drop down another -2. So hopefully you didn't have a problem with that. I know maybe you've been off for some time from math, so you need to build those skills back up again. What's the take-home message here? If there's more than one sign, okay, so in this case here we have 2 negatives. If there's an even number of negatives before the number, your results are going to be a positive. So even number of negatives, even negatives turns into a positive. 2 negatives make a positive. 4 negatives make a positive. 6 negatives make a positive. All it has to be is an even number of negative signs. On the flip side there, odd number of negatives make a negative, right? We have an odd number of negatives, so we can have, this gives us a negative. So we have negative and a positive. That is going to be a negative. These rules apply for both multiplication and division. Please note that. Let's move along then. The word term. This is extremely important you fully understand this. This will be important next semester in Math 273. We start getting into calculus, and you have to differentiate terms separately. So what is a term? Well, a term is any value that's separated by a positive or negative sign. Remember that. In this case here, we can have two terms. We can have 3 plus x. These are two separate terms. 3 is one term and x is another term. We can have two numbers that are separated. 3 plus 5. Now, those are two separate terms technically, but of course we can combine them as a single term. In the other case here, we cannot combine that right now unless we knew the value of x. Single terms now. What it represents one term. If I had 3 times x, notice these two values are not separated by a positive sign or a negative sign. Therefore, they are representing one single term. The single term could be represented as 3x. Again, you don't see anything separating those two values, so you would take the value of 3 and you'd multiply by the value of x. In addition, we can have 3 divided by x. Once again, you see the 3 is in the numerator and the x is in the denominator. These two values you might think they're separate terms, but they're not. They're not separated by a positive sign or a negative sign. They're separated by a division sign. So in case this is one single term. And this will be important later on when we get into more complex mathematics. What does it mean when we have a negative sign in front of your brackets or your parentheses? Remember, parentheses here, it groups all those numbers together. The 6, the 5, the 3, the 2, and the 4 are inside those parentheses. So they're grouped together. So what we have here, we have this negative sign outside the brackets, and it must be distributed. The negative sign goes here in here, and now we have positive 6 times the negative. And you can say this would be maybe -1. You could assume it's a -1. In this case here, this becomes -6. We distribute it to the 5, becomes -5. Distribute to the 3. Here we have a negative and a negative. What happens when we have two negatives? It makes a positive. So this switches to +3. Again, the negative to the -2 becomes +2, and the negative to the +4 becomes -4. -6 minus 5, -11, plus 3, plus 2, -4. And then we have -11 plus 3. In this case, we have -8 plus 2 -4. And then we'll take -8 plus 2. We have -6 -4. And in the end, we have -10. You'll see quite often when I get a final answer, I usually put a box around it. This is just what I've learned to do over the years. It helps organize and tell the instructor or myself where exactly the final answer is. Because later on, it can get kind of messy sometimes. Now, be careful, though. Oftentimes, what students do incorrectly is they'll say -6 plus 5 minus 3 minus 2 plus 4. That's just this copied down. What they do is they say this is equal to -6 plus 5 minus 3 minus 2 plus 4. So what they've only done this part, and they forget to do the rest of the numbers. These things are not equal to each other. So be careful. That's why I would recommend using the arrows or the rainbow. That way you know what's going on. Let's try the next one. Solve this value. So here we have solve in brackets -2 and then in brackets -3. So what does this mean between the two? It means we're multiplying them. So we have a negative and a negative. What happens when we have two negatives? Two negatives make a positive. 2 times 3 is 6. So the answer to this is going to be +6. Over here, we have 8 times -5. We have a positive times a negative. Remember the rule we just talked about? If there is an even number of negative signs, the value in the end will be positive. If there's an odd number of negative signs, only one negative sign there, that's a positive sign, then the value will be negative. So this is going to be negative, and of course 8 times 5 is going to be 40, so the answer to this is -40. Now hopefully you already have this in your rote memory, you know how to do this in your head. If not, you might want to practice that, work on that. Now some more terminology. Absolute values. So absolute values is when we don't care about whether a value is positive or negative. We just care about the magnitude, how big the number is, whether it's positive or negative. So we don't care about whether it's moving in the left direction on the number line from 0 or the right direction on the number line from 0. This often becomes more important in your physics class when we're talking about magnitude of a value. Also in statistics, oftentimes we don't care about the positive or negative sign. We only care about how big the number is. So as an example for that, you can see we have 25, and on the outside we have these lines here. Those lines represent the absolute value. And all we do is whatever's inside the line, we pretend that that's brackets. We do what's inside the math first. And then whatever the answer is, we make it a positive number. So this is equal to 25. Likewise here, we can see we have these absolute values around minus 25. So we just take what's inside there and we make it a positive value. Same deal. We have 4, becomes positive 4, negative 4, becomes positive 4. So in essence, all an absolute value is doing is getting rid of any negative signs, making everything positive. And you're going to work with this quite a bit in statistics. Well, that's all I had planned for this lecture, the basic sine numbers, very short lecture. Hopefully this wasn't new knowledge for you. Hopefully this was just refreshing knowledge you already have. Remember, the first several lectures in this series are going to be the very basic fundamentals. Trust me, as we move along, things are going to get a little bit more difficult and hopefully more interesting.